All right, everybody, welcome to the video here for lesson number 7 on finding volumes. So in class today, we worked on a couple different shapes and finding volumes using the volume formulas from our reference sheet. So in this first example, we have what's called a composite solid, a solid that's a combination of two three-dimensional figures. So to be able to find the volume of this, we have to find each individual volume and then add them up. So first shape that I see is a cone. So the volume of a cone is going to be 1/3 pi r squared h. So the volume of the cone is 1/3 pi r squared h. Now in this picture, I see that the 5 becomes the radius because it's half the distance of the cone's base, and 12 is the altitude or the height of the cone. So the volume of the cone is 1/3 pi times 5 squared times 12. Now this answer wants to be in the nearest hundredths, but this cone's volume is just part of the total solids volume. So when I type this in the calculator, I'm going to put in pi and I'm going to put in all the other parts here. But when I get the answer, I don't want to round it to the nearest hundredth now. I want to do that later. So the volume of the cone is going to be 314.1593. So notice I'm going 2 places past the nearest hundredths place. So I could see if that is going to affect how I round the total answer. Now, the volume of the hemisphere is going to be half of the volume of a sphere, 4/3 pi r cubed. Or 4/3 pi r cubed divided by 2. Either way, however you wind up doing it. You already know the radius because the radius of the sphere is the same as the radius as the cone because they kind of fit on top of each other. So the volume of the hemisphere is 1/2 of 4/3 pi times 5 cubed. Now this just becomes a calculator problem. Again, I'm going to round well past what I'm asked to round to here. So if I do this in my calculator, I get 261.7994. So then if I find the total volume, I just have to add those two numbers together. Now, if you have the newer calculator, you could kind of just scroll up and you don't have to worry about the whole rounding thing. If you have the older one, just use the numbers we just rounded to. Since they're past what I'm asking you to round to, we're good. And if I round this, I should get 575.96. That's to the nearest hundredth. The second question talks about this bathtub. It says it's a rectangular bathtub, so this is going to be a rectangular prism. So this is the only volume formula that's not on the reference table. Pi L times width times height. It says it's filled 2/5 of the way with water. The bathtub has a length, width, and height of those dimensions. Determine the volume of the water in the bathtub. So first I want to find the volume of the bathtub, then I'll multiply that volume by 2/5. So there's a couple things that are going on here. First, I know the length is 8. The width is 3 foot 6 inches. Well, 6 inches is half a foot. So this is going to be 3.5 feet. The height is 2 feet 8 inches. 8 inches is 8 out of 12, which if I divide those two numbers, I wind up getting 0.6 repeating. So that's going to be 2.667 of a foot. Again, it's not 2.8 feet. This is something that's come up a few times in different areas in this course. So the volume of this bathtub is going to be 8 times 3.5 times 2.667. So if I do that math, so if I do 8 times 3.5 times that decimal, I get a volume of 74.66 or 676, sorry. Now that's the volume of the total bathtub. The volume of the water is 2/5 of that. So if I take 2/5 of this 74.676, I get the total water volume, and it says nearest cubic foot, so 30 cubic foot. It comes out to be 29.8-ish. The last question gives us a cup. So it says a cup in the shape of a right circular cone. So I have a cone cup. Is being used to fill the bucket in the shape of a right circular cylinder with sand. So here's a bucket, right circular cylinder. So we know what it looks like. So that was the whole point of those early lessons where we're talking about all that vocabulary. It says the cone has an altitude of 6 inches. Altitude is the fancy math word for height. And a radius of 3 inches. Notice both are inches, so that's good. So I should be able to find the volume of that cone pretty easily. The bucket has a height of 24 inches and a diameter of 20, which means it has a radius of 10. The reason why I know that I'm going to need radius is because of the volume formula for a cylinder. So if we find the volume of each, so if I find the volume of the bucket, since it's a cylinder, it's pi r squared h. So the volume of the bucket is going to be pi times 10 squared times 24. I'm going to leave this in terms of pi because I don't want to really round it. It'll be easier if I do this in terms of pi. So if I do 10 squared times 24, that's 2400 pi. So that's the volume of the bucket. If I want to find the volume of the cup, that volume formula is 1/3 pi r squared h. Right on the reference table, no thinking involved there. And if I plug in what I know, so I know the volume of the cup, the volume of the cup is then going to be 1/3 pi times 6 squared times 12, right? It was 6, oh no, that's way wrong. The radius was 3 and the height was 6. I knew it was double. So the radius is 3 and the height is 6. So if I find the volume of the cup, if I plug that in, so if I do 1/3 times 3 squared times 6, we get 18. So that's 18 pi. Notice I left both in terms of pi. Now to figure out how many cups of sand I would need to fill up this whole bucket, I need to divide these two numbers, because it's asked how many cups of sand would fit in a bucket without overflowing. So the number of cups is going to be equal to 2400 pi divided by 18 pi. The pi's cancel, so I could just do 2400 divided by 18. So that's going to be 133.33 ... Now, that means I can take 133 full cups and put it in the bucket, and then I should be able to take about 1/3 of a cup and put that in the bucket. But this says how many full cups can we fit in the bucket without overflowing. If I was to do 134 cups, it would be too much. There would be sand overflowing over the top. So I can fit 133 cups in this bucket. That's your homework assignment. Hopefully this video helped. Make sure you're studying and understanding all of the different types of questions in class. There is one thing I want to mention to you is when we're finding volumes, I can't possibly go over every scenario in class. We don't have time. So your homework assignment, and if you're watching this video, that means you're doing it, is extremely important, and that's how you'll get good grades on your tests and quizzes for this chapter. Best of luck on your homework, and I will see you all in class tomorrow.